So this is unit 1 from June 2022. We'll do the MCQs. Element in their most stable state exists as how when elements are stable, how they exist, the most stable state. So when you check the options, the first one, atoms in giant structure only. No, like we have other structures as well. Atoms in molecule and atom in giant structure only. Look, the question is how element can exist. So element can exist as a single atom, like atom only, like group 8 elements. It can exist as a giant structure, like carbon, diamond, graphite. So the carbon is there, so it's a giant structure. Or it can also exist as a molecule as well. Like example, oxygen is O2. So oxygen can exist as O2, as a stable. So they can exist as atom, they can exist as molecule, or they can also exist as atoms in a giant structure. That's why D is the right answer. So element can be atom, element can have a giant structure, element can be a molecule as well. A sample of a nitrogen gas contained 1.20 into 10 to the power 24 molecules. What is the mass of this sample? So first we'll work out the moles equal number of the particles, which is 1.0204 into 10 to the power 22 divided by Avogadro's constant 6.02 into 10 to the power 23. That is Avogadro's constant. And after getting the moles, we need the mass in grams. So we have the formula moles equal mass in gram divided by molar mass. So molar mass multiplied by moles. So moles multiplied by molar mass, we'll get the mass in gram. So these are the moles 1.02 into 10 to the power 22 divided by 6.02 into 10 to the power 23. These are the moles. And what multiplied by the molar mass, it's a nitrogen gas. So nitrogen gas is N2. If it was a nitrogen atom, we'll take that as N. But nitrogen gas is N2. Each nitrogen is 14, so 2 nitrogen will be 28. So the molar mass or the molecular mass will be 28. So this, when we simplify, we get 0.56, or C will be the right answer. When magnesium oxide react with a sulfuric acid, what is the ionic equation for this reaction? So how to write an ionic equation? First, we cancel out the common ions in the aqueous solution. So what are the common ions in aqueous solution? We have aqueous sulfate is there, so we cancel sulfate ions. Rest other cannot be cancelled. Solid, liquid, and gas we write as it is, so it will be MgO plus in aqueous 2 hydrogen ion gives 1 magnesium ion plus 1 water molecule. So it will be B. A solution of a sodium chloride NaCl is prepared by dissolving 10 gram of a solid and making a solution up to 250. What is a concentration? What is a concentration? Concentration is moles divided by volume. How to work out the moles? Moles equal mass in gram divided by molar mass. So 23 plus 35.8, so this will be 58.5. This will give us the moles. And the volume is in cm cube, we have to convert it to dm cube. So moles will be 10 divided by 58.5 and the volume is 0.25 because divided by 1000. This will give us a concentration. So when we simplify this, like after solving, we'll get B as the right answer. The 10 test tubes each contain 1 cm cube of a chromium chloride solution with a concentration of 0.1. Different volume of a silver nitrate of the same concentration was added. Silver react with chlorine to form silver chloride. What is the formula of a chromium chloride? Look, first we'll take a ratio between how many moles of silver nitrate Like, what is the volume ratio between them? At this point, like when we add 3, this is the height of the breast plate. After 3, the height is not changing. So, like the chromium chloride is reacting. We don't know which chloride, but what actually happened, we have one Cm cube is reacting with Cm cube. So, the ratio between them, the silver nitrate and the chromium chloride, we don't know how many are there. The ratio between them is 3:1. Like 3 molecules, as you can see, the concentration is same. So when the concentration is same, the volume ratio is equals to the mole ratio. Or volume ratio, you can also take the mole ratio as well. Now 3 molecules of this required 1 molecule of a chromium. So when they react with each other, it will form AgCl plus chromium nitrate. So the question is, what is the formula of the chromium chloride? So how we know? Because we are using 3 times the volume. Like 1 Cm cube required 3 Cm cube for forming the precipitate. So how many chlorine are there in this chromium? It means it contains 3 chlorine. So the formula of the chromium chloride will be C1 chromium and 3 chloride. So that's why D will be the right answer. Is it clear? Because if it is AgNO3, it reacted with chromium 3 chloride. What will it will 3 molecules of chromium, as a result 3 molecules of silver nitrate react with chromium chloride. It will form silver chloride 3 molecules plus chromium nitrate. So how many molecules are there in this? If 3 molecules, so we need like 3 moles of chlorine are there, so we need 3 moles of silver nitrate solution. If 4 were there, we need 4. If 5 were there, we need 5. So the ratio of the volume will give us a formula. Is it clear? In question 6, part A and B, atomic number of scandium is 21 and has a mass, its only isotope is 45. What is the number of electron in scandium plus? So if atomic number is, so it will have the 21 protons and 21 electron in an atom. But if it is +1 charge, so it will have 20 electrons. Because the electron is being lost. Whenever atom turn into a cation, the positive ion, the electron will be lost here. Then in a mass spectrum of scandium, +1 and +2, the mass to charge ratio value for peak due to scandium +2. So M by E ratio, so mass of a scandium is 45 and the charge is +2. So 45 divided by +2. So this will be 22.5. Because the mass to charge ratio, mass divided by charge. So mass is 45 and the charge is 2 plus or +2. Which equation represent the first ionization energy of iodine? The first ionization means energy needed to remove electron from neutral gaseous atom. So how much energy we need to remove electron from a gaseous atom? Like it should be gas and it should be atom. That is known as the ionization energy. And remove the first electron. What is electronic configuration of a nitrogen atom? So nitrogen, because it is 7, the proton number, so electron will also be 7. It will be 1s2, 2s2, 2p3. So first shell electron in a box model, P will have px, py, and pz. So they will occupy an opposite spin, one clockwise, anti-clockwise. Then first they will occupy singly. So A and B are totally wrong because the 2 electrons have the same spin. C and D can be answered, but when you check first for C, also initially when they occupy the p orbital, they occupy with the same spin, single, and then they pair up. But here what it shows one of them is opposite. That's why C is the right answer for this. In question 9, the element manganese has an atomic number 25. What are the number in S, P, and D electron in an atom? So when you write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, that makes 20, and then 3d5. So how many total number of S electrons are there? So this is S, 2, 4, 6, 8. So 8 electron in total S. How many in P? 6, 12. So in P there are 12. And how many are in D? So D is only one D is available. That is 5. So 8, 12, and 5, the total number of electrons. So that's why B is the right answer. Which row in the table shows the correct forces in a crystals of a lithium iodide? Lithium iodide is an ionic compound. So lithium will be positively charged and iodine is negatively charged. So there will be electrostatic attraction between them, strong electrostatic attraction between the oppositely charged ions. So there will be attractive forces between the ions of opposite charge. That's correct. There will be repulsive forces between the ions with like charges. That's also correct. Like example, when we draw a lattice, say this is lithium ion, then iodide, then lithium iodide, then iodide, lithium. So between the two, there will be a repulsion. Some covalent bonding forces. Yes, it will be there. Why covalent bonding forces will be there? Because when the ions have like positive and negative ions have different number of electrons, so this is called a polarization. And this polarization depends on the charge of the positive ion should be large and the size of the positive ion should be small. And for negative ion, the charge should be it's large charge should be there and it should have a small and large size as well for a maximum attraction. So some covalent bonding like this distortion result in some covalent bonding. So that's why D is the right answer. So even we have an ionic compound. Ionic compounds also have covalent nature. But for example, if it was sodium fluoride, so sodium fluoride, sodium ion contain 10 electron and fluoride ion also contain 10 electron. In this case, they have the same number of electrons, so there will be no covalent bonding. Because to have this ionic bond, to have a covalent bonding or nature, there must be different number of electron in the ions. Some physical properties of the 5 substances are listed. Which of these substances could be metal? If a substance is a metal, it should have a high melting point. So when we check options N is this, solid is good, liquid is good, solution in water insoluble. So N shows that it's a metal. L is poor in solid, so L cannot be. So any option with L is wrong. Then we check M is a good conduct, good react, and it is a low melting point. M can be also a solid. Why it can be a solid? Because solid can conduct. It can look two ways. Two type of substances can conduct electricity in a solid. One is a giant structure such as graphite. Another one is the metals. So if it was a giant structure, then it will have a high melting point. So means it's not a giant structure. So what it shows, it is also a metal. So M is a metal. M is actually an alkali metal. And N is a transition metal. So C is the right answer. So even from the first property that they conduct electricity and the last property about the melting point can give you an idea. Because if it conduct electricity in a solid, so it can be a giant structure or it might be a solid metallic structure. And the metal with a low melting point, metals with the low melting point exists. So it might be a metal with a low melting point like alkali metal. That's why C should be the right answer. Which substance has a property showing that it changes from a molecular structure to ionic when dissolved? Like first it is molecular structure when it is not conducting, and then it start to conduct. So first in a liquid state, like the molten state, it was molecular, not conducting. But when we dissolve, it start to conduct. So which substance start to conduct? Q start to conduct, because ionic structure means like ions are free to move in a solution, so it start to conduct electricity. In question 12, at 180 aluminum chloride exists as Al2Cl6. What is the structure? It is a dative bonding is there between aluminum and the chlorine, and the electrons, look, in a dative, it is AlCl3 and another Al. So it has a lone pair. This lone pair is attracted towards, like chlorine is giving its lone pair to aluminum, so aluminum becomes stable. And same thing, this chlorine is giving lone pair to aluminum, so it becomes stable, means forming a dative bond. So when we draw, like these two are totally wrong because it shows all are covalent, but it's like a one molecule of AlCl3 covalent dative bond is there between another molecule of AlCl3. So they link with each other. When carrying out chemical experiment, the hazard and the risk must be considered. For a given chemical, so hazard is fixed. Like example, if I say something is poisonous, so that is a hazard. So hazard is fixed. Hazard cannot, like something is poisonous, like if we say chlorine is toxic, so it will be toxic even it's a large or a small amount. But we can reduce the risk. How we can reduce the risk? By either reducing or lowering the concentration which we use for in the experiment. So hazard is always fixed. Like something is poisonous, something is corrosive, something is can cause a cancer. So these hazards are fixed, but risk can be minimized by changing the scale, like using low concentration, using low temperature conditions. Heterolytic fission produce, heterolytic means unequal bond breaking. So as a result, like example, if H and Cl is there, so when a heterolytic bond breaking, both of them taken by one, so it will form H plus and it will form Cl minus. So it will produce the positive and negative ions. So it will produce ions only. In a homolytic, it will produce a radical. Hydrocarbon X has a molecular mass of 98. When a sample of X is shaken with bromine, the color of a bromine does not change. So means if the bromine color does not change, it is not alkene. Then we have to count like 1, 2, 3, 4, 5, 6, 7. So this is C7. And because it's an alkane, so H should be 16. So the molecular mass, this will be 12 multiplied by 7 plus hydrogen is 16 into 1. So that will make 84 plus 16. So 84 plus 16 makes 100. This cannot be. 1, 2, 3, 4, 5, 6, 7, 8. So obviously this mass won't match with 98. And when we check 1, 2, 3, 4, 5, 6, 7, and it will have less hydrogen because one of the hydrogen, it's a cyclic alkane. So cyclic alkane, the general formula of cyclic alkane is same as alkene. So if C7, H will be 14. When you work out 12 into 7 plus 14 into 1, so this will be 84 plus 14, that will make 98. So the total mass of a D will be 98. This is also mass is 98, but because I mentioned it does not decolorize the bromine, so it cannot be alkene, it should be alkane. Why 14? Because when you check, it is a cyclic alkane. The cyclic alkane, the general formula of cyclic alkane is CnH2n. It is same as alkene. And you can also count that like this will have two hydrogen, 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 this will have three hydrogen, this will have three hydrogen. This won't have any hydrogen, only carbon will be there. So when you even count like this, you will get the same result. Which of these amphoteric pollutant is not emitted during a combustion? So in a combustion of it produces oxide of nitrogen when nitrogen react with oxygen. Sulfur, some trace of a sulfur is there, so sulfur dioxide is also produced. Octane, unburned carbon, petrol is also released, but ammonia is not there. Ammonia is produced when nitrogen and hydrogen react in the presence of iron as a catalyst. Under a very high pressure, it produces ammonia. But in a petrol, combustion of petrol does not produce ammonia. Propagation step, the steps for first one is initiation, in which we produce a radical, then a molecule. This is a propagation. When a molecule react with a radical, it will produce a methyl radical plus HCl, and then the methyl radical react with another chlorine to form a methyl chloride plus chlorine radical. And then the last one is a termination, in which chlorine radical react with chlorine radical, methyl radical react with methyl radical, or chlorine radical react with methyl radical. This is a termination, this is a propagation, and this is the initiation. We need a propagation. So in a propagation, a molecule should react with radical. Here two radicals, no. Here a molecule is there reacting with a radical. Here, but as you can see, like CH4 is not involved. Here two molecules are reacting with each other. And in this one, like we don't have a methyl radical and methane. Methyl radical, what it react with, if we have a methyl radical, it react with chlorine. So that's why this reagent is not correct. This is correct, but this is not correct. So B is the right answer for this. What is the iopic name of this compound? So when we name, we select the longest chain of a carbon. So 1, 2, 3, 4 carbon are there. The numbering should start from a nearest branch. So if we count from here, it will be 1, 2. If we count from other side, it will be 1, 2. The branch is also closer when we count from here. So we will count that as 1, 2. So second position, we have a chlorine. So it is 2 chloro. And 1, 2, 3, 4 carbon are there. So it will be bute and 2ene. So 2 chloro, bute, 2ene. But what about the nature? Is it cis or trans? Cis and trans it cannot, because cis and trans are the term which we use when we have identical groups are attached. Like if CH3 was here, another CH3 is there. So when we compare the identical groups, their position, then we use the term cis and trans. But here we cannot use the term cis and trans. So it can be E or Z. E means opposite side and Z means same side. So when we check the heavy groups in terms of their mass, so this is a heavy group. When we check heavy, this is heavy. So heavy groups are on the opposite side, so we'll use the term E. So it is E2-chloro-butene. That's why C is the right answer. Is it clear?